In this video, we're going to look at how to expand and factor with algebra tiles, or Alge-tiles. In order to successfully do this, we need to understand a few vocabulary terms. To simplify means gathering together any like terms. So x squared plus 7x plus 2x would become x squared plus 9x. We also have to understand that expand means to multiply, or get rid of the brackets, and keep in mind when we expand we should always simplify our answer. The last instruction word that we should understand is to factor. That means to find what's been multiplied together, or to put the brackets back in. As a few reminders of what we've discussed in class, when we talk about the edge lengths of a rectangle, especially a rectangle with algebra tiles, those edge lengths represent the factors. And the total area of the rectangle represents the product, or the expanded form. When working with algebra tiles, one of the most important things to remember is that a shaded algebra tile is positive, and an unshaded algebra tile is negative. The other thing to keep in mind with algebra tiles is their value. The large squares we generally tend to say are x units wide and x units tall, so that they have a total value of x squared, and then the unshaded large square is negative x squared. The rectangles are x units wide and 1 unit tall, so that they have an area of x, and the unshaded version is negative x. This is true no matter what orientation we put them in. Lastly, the small squares each have a total area of 1. They're 1 unit wide and 1 unit tall. So a small shaded square is a positive 1, and a small unshaded square is a negative 1. There are a few things to keep in mind when you work with algebra tiles. The first of these is that our rectangles always have to be perfect or complete. In this case, there's a gap at the bottom of our rectangle. If we trace its outline, there's a bite taken out. That tells us that there is a mistake. The second thing to remember with algebra tiles is that we should never have any zebra stripes or anything that looks like a QR code. We would expect to see something that looks more like this, with all 3 positive tiles on one side and both negative tiles on the other. The last thing to remember for now as we work with algebra tiles is that we have to be careful to follow the rules for multiplying integers when we're filling in our ones. For example, a positive multiplied by a positive means that this one's unit should also be positive, along with this one. And a negative multiplied by a negative means that this one's unit should be positive. But where we have a positive multiplied with a negative, in 3 different cases, those tiles are correctly unshaded. And again, we get back to the problem of looking like a QR code and having zebra stripes, so we know that there is an error. Keep in mind that in class we discussed how your textbook uses a different color scheme. Your textbook says that yellow tiles are positive and red tiles are negative. Well, guess what? We don't care what your textbook thinks in this case. We always stick with what we've already said. Any tiles that are shaded will be considered to be positive, and any tiles that are unshaded are considered negative. So let's talk about using algebra tiles to expand k by k subtract 4. One edge of our rectangle will be k units long, the other edge of the rectangle will be k subtract 4. And keep in mind, it doesn't matter which edge is which. Once you have your 2 edges drawn, extend your lines to finish the rectangle. Next we consider our shading. In this case we have a positive k multiplied with positive k, so this tile will be positive, and it will look the same if we have our drawing in a different orientation. But we have negative 4 multiplied by k. That'll give us negative 4k's, so these tiles will be negative. Lastly, don't forget to write down what your picture shows you. In this case, we have a positive k squared and we have 4 negative k's, so we'll write that down as negative 4k. Here we're going to use Alge-tiles to expand n subtract 3 and n subtracting 5. We begin by drawing our edge lengths. Once you have your edge lengths drawn that show us n subtracting 3 and n subtracting 5, we're going to extend these lengths to complete the rectangle. Now we're looking for our shading. Positive n and positive n. This tile will be positive. The next few tiles I consider come from negative 3 multiplied by n. These tiles will be negative. And these tiles come from a positive n multiplied by negative 5. These tiles will be negative. The last set of tiles come from negative 3 multiplied by negative 5. That's going to give us a positive answer, so each of those tiles will be positive. And we do enough shading to show someone looking at our picture that we intend for these tiles to be shaded in or positive. Lastly, we write down our answer. This picture shows us positive n squared, negative 3n, and negative 5n, so altogether negative 8n's, and a total of positive 15 ones. What if we're asked to look at an expansion like this, involving an x squared? Well, we certainly know how to draw an x squared tile, but we don't know how to draw a tile that is x squared units long. That's an area, not a length with our algebra tile model, which means in this case, we simply can't use algebra tiles, and we'll look at one of our other strategies. When using algebra tiles to factor, we do the same thing but in reverse. We begin by figuring out what the rectangle looks like. In this case, we need one x squared tile, 3 x tiles, and 2 1s. We arrange the tiles to form a complete rectangle with no gaps or extra parts jutting out, and we make sure that we haven't made any zebra stripes. Now we're going to read our factors from the edge lengths. One factor is x and 2 1s, so x plus 2. The other factor is x plus 1, so that our factored form final answer looks like x plus 2 multiplied by x adding 1. And keep in mind we could also write that down as x adding 1 multiplied by x plus 2. Now let's consider using Alge-tiles to factor t squared subtracting 5t plus 6. Remember that the Alge-tiles can work for any variable we like. Let's imagine this is the first algebra tile diagram that you create. This algebra tile diagram shows us t squared, and it shows us negative 5t's, but then we get into trouble. This picture only shows us positive 4 1s, which means this picture doesn't work, and we have to try again. This second picture now shows us t squared subtract 5t adding 6. It's the correct diagram to help us out. Looking at the factors, we have an edge length of t subtract 2 and another edge length of t subtract 3. The factored form then is t subtract 2 multiplied by t subtract 3. Try to figure out what the picture for using algebra tiles to factor b squared subtract 9 should look like. Here is our correct picture, and don't be afraid to use other strategies you've learned in class to help you figure out what the picture should look like. Don't forget in the end to write down your factors. One of the most powerful uses for algebra tiles is to help factor when we can't find a common monomial, when the product and sum rule won't help, and when we don't fit the perfect squares or difference of squares pattern. So this case is a lovely time to try using algebra tiles. In order to successfully find the rectangle that works, we have to notice that we need to add a group of 0. One positive tile and one negative tile add up to represent 0. This is a strategy that you can use at any point in time with algebra tiles, but is very common particularly when we have a negative number of 1s, because we know that negative 1s only come from positives multiplied by negatives. If we don't have any positives or negatives described for us, we need to add 0. And before you decide that you're done, don't forget to write down the factored form represented by your picture. Many students, once we've showed them how to use algebra tiles, love this strategy and will use it on a regular basis. Other students find drawing pictures to be either a waste of time or paper, and they would prefer to use other patterns. It's your choice of strategy, but keep in mind, this course is going to require you to show that you understand both using algebra tiles to expand and to factor. You should use algebra tiles in your work when the question says either algebra tiles or area model as part of the instructions, and also when you're having trouble successfully factoring using one of the patterns from class. Keep in mind for quizzes, tests, and especially your exams, you are always allowed to ask for some algebra tiles.